So, students, I am GP Singh, and we are here for studying physics for class 11th Foundation Physics. And yesterday we have just started the H.C. Verma book, The Concepts of Physics. So, students, GP Singh, and we are for studying physics. Class 11th Foundation Physics, and yesterday we just started the concepts of physics. So, in continuation with the last class, which occurred yesterday, we are going to study the first chapter of H.C. Verma book, that is Introduction to Physics. Now, we studied what is fundamental units and derived units. You might have been having some idea of fundamental units and derived units like area and speed, velocity, etc. are for derived units, and mass, length, time, and electric current, thermodynamic, temperature, etc. are basic units or your fundamental quantities. So its definition is very easy. Of the meter and kilogram and second, ampere, etc. Let's have a view of it. So it is defined in such a way that in any situation, its value must not change. Suppose in today's world, we are here on the earth, and after few decades, mankind may start living on the Mars or Moon or any other planet, or suppose we are having a space station, or anything else can be possible. So meter is defined in such a way that any part of world, not the world, any part of universe or anywhere else, its definition is not variable, not changeable. It is defined as the meter defined as the distance traveled by a ray of light. By light in vacuum. Here, this is important. Light in vacuum. Although so many other conditions should also be defined, but that is not, at present we are not concerned with it. In 1 second, light ray travels how many distance? 299,792. In 1 second, light travels this much distance. So, reverse of that quantity when measured in second is the distance traveled by light ray in 1 second is called a meter. In this fraction of time, the ray of light travel whatever distance is called 1 meter. The only condition is that it should travel in vacuum, right? Now, what is a second? For that, we take cesium atom. Cesium is an atom, is a substance. Cesium 113. Not all cesium. Cesium may have other atomic weights also. So one cesium atom which is having atomic weight of 113 units of atomic unit, what we call. So it is emitting light rays. So light rays, sometimes it behaves like a wave, like this. And from here to this point, from this point to this point is called one vibration. Likewise, from this point to this point is called second vibration, and third vibration likewise. So in 1 second, second is defined in such a way that one time period is in such a way that in 1 second it is having 9,192,631. 9,192,631 dot, no, not dot, it is 770. But I'm trying to say that if we take cesium atom, it's a thought experiment. What I am going to tell you, but there are means where we can measure such vibrations. But in thought experiment, suppose you are having a cesium atom and a light ray is being emitted from it, and we are able to count the number of times the light rays are doing vibrations, and one time period we are able to count. Then if we count such amount of vibrations, and then we will find that after this vibration whatever time we are counting, that will amount to be 1 second. It means in 1 second, the light ray will vibrate or will have such time period, such number of time period. 9, 192, 631, 770. I don't think that this quantity you have to remember by heart, but this is enough for anyone to understand the speed with which the light rays vibrate. And it is defined in such a manner that at any place of this universe, you go and start counting with your practical setup, and then you will find that after such number of vibrations, the time elapsed will be called 1 second. And in 1 second, light rays will travel this distance 1/299,792,458 kilometers, right? So there is no need to get confused with the time period and distance travel. Time period is different and distance traveled is different, right? So these are the examples with which we define our fundamental quantities, so that in any situation, it's standard for all, and no need to have their own set of fundamental quantities, whether we live in India, whether we live in China, whether we live in Sweden or any other part of world. At present, most of us live in Earth, but these things are required and may be required in future in other places also, which are far from the Earth. So likewise, other fundamental quantities are defined, and you can go through it and find what is there written in book. That's not very difficult to understand, very difficult to comprehend. And in this way, we now have finished the dimension and units, right? What is the need of units? I think I have already taken one class last month, but since students demanded that a fresh class stream should be started, so I started yesterday afresh, right from the first chapter to the end of the book. Okay. Now, uses of dimension. Dimension, you all know that this is mass, this is length, this is time, and this is current, ampere, this is mole, molecular number, and this is temperature, this is light. These are the fundamental units with the help of which we can express any other other unit. Very common is this force, because with the force almost all of us are very much familiar with the concept of force. And force can be expressed with the help of these, not all, but few of these can be used to express the force. Like yesterday, we have seen the area. Area is length square, and speed is length upon time. So in this way, so in the same manner, force is mass into acceleration, mass into mLT t square. So like speed, acceleration is having LT upon 2. So this way we can express force, and you can understand how other quantities can be derived from the fundamental quantities. So one quantity can be expressed with the help of other fundamental units. Likewise, any unit you will come across a lot of units. Like so many coefficients are there, and other units like current and voltage and charge, and there are so many like voltage, charge, elasticity, and so many units are there. These all can be expressed with the help of these fundamental quantity, fundamental units. So I think this chapter is almost finished. One thing is there: use of dimensions and conversion of unit and reducing relation among the physical quantities. With the help of dimensional analysis, one method is there that is called dimensional analysis. Suppose in any unknown sort of equation, you know what is equation? Equation is simply a relation between two or more quantities. And they are equated with certain law. With certain law which we observe. So equation matlab to equate. Like velocity, or rather you say speed. It is a little bit confusing if we use velocity. It will create confusion. Say speed. Speed is very simple thing. We are all familiar with the speed. Speed is measured in the meters per second. So V is equal to distance upon time. distance upon time, right? Likewise, force is measured as mass into distance upon time square. So these quantities are derived unit and two fundamental units should be equal in so many respects. I mean, the left hand side should be equal to the right hand side in so many, in almost all respects. Dimensional analysis means what is the power of any dimension, fundamental quantities, like in area. Suppose we deal with area. It is length into breadth. Both are measured in the meter. So it is having L MLT minus M. It is measured with only the help of length, area, and it is having double power of length. ठीक, तो दो पावर लेंथ की है. इसी तरह से यदि हम एरिया अगर करने की बात करें तो इसमें लेंथ अपॉन टाइम, दोनों लेंथ और टाइम की सिंगल पावर, राइट. बोथ आर हैविंग single power, and rather L is 1 and T is -1 because it is below the this line. It is division line and it is below of that line. Now we move to the acceleration. Acceleration is velocity, changing velocity with time. It is velocity upon time. Suppose velocity is increasing or decreasing constantly or rapidly, then its acceleration is measured. In that case, velocity is changing. So in that case, acceleration will be measured in the length upon time. This is already acceleration, velocity, and again time. So it will be expressed as LT square or LT minus 2. What I'm trying to explain is the power of fundamental units in this equation. In this equation is acceleration, which is usually written as this, is LT minus 2. When we define force, mass also comes into the consideration, and this becomes MLT minus 2. Right? So it is, the force is having, if we take all the 7-8 dimension, 7-8 fundamental quantities, it can be expressed as 1, 2, 3, 4, 5, 6, 7. So it can be expressed as M1, L1, T minus 2, and that A0, A0, mole 0, CD0, 1, 2, 3, 4, 5, 6, 7. All 7 fundamental units are involved, and it can be expressed as the different power of different fundamental quantities. All other are having power 0. It doesn't make the whole equation 0, because anything power 0 is 1. And 1 multiplied by any other thing remain unchanged. Right? हरिओम, आवाज जा रही है? अच्छा, so in this way, sometimes it happens that we are having an equation where on left hand side we are having an unknown quantity or something, some result, and on the right hand side we are having a mixture of fundamental quantities. And if we know the power of all the fundamental quantities, power means their coefficients on the top of their head, then we can define and decide the total nature of this quantity. Right? Like suppose distance traveled by a moving vehicle. It is expressed as equal to ut plus half ut plus half at. Sorry, this is at. Here u is initial velocity, t is time, half is a constant, e is the acceleration, and t is again time. And we know all such things. So u is velocity. Velocity is having dimension of m upon p. Time is having dimension of t, and half is a single number. Acceleration is having dimension of, sorry, it is not m here, it is only l t squared, and then again time is there, and time is having power of 2. And we are not knowing the nature of this quantity. What is this, and what is the dimension of this, and what it is carrying with it. So if we compare it with this one, if we compare with the left hand side quantity with the right hand side quantity, we are not concerned with the magnitude. We are only concerned with the dimension of this quantity. So, and we will write the dimension of all the terms in the right hand side quantity. And this comes out to be t is cancelled by t square is cancelled by t square, and the, sorry, this is L, length, not mass. So it comes out that right hand side contains only dimension of length or distance. So the left hand side will contain only dimension of the distance. In this manner, suppose we already know the nature of this equation. In this manner, we can also establish the authenticity of this equation, whether this equation is correct or it may have something wrong. This is the necessary but not sufficient. This is the necessary condition but not sufficient. There may be other conditions also to check the authenticity of any equation, but this is the necessary condition. Any equation, whether it is simple equation or very complicated one, very long one, if equation is there, there must be one equality sign someplace, and left hand side quantity is equal to right hand side quantity. To check whether this equation is right or not, we always perform the dimensional analysis, and left hand side dimensions are computed and right hand side dimensions are computed, and then they are compared. If their comparison comes out to be equal, they are all having equal number of powers of dimensional fundamental quantities, then it is said that this equation is, or it may be correct. Then it is again subjected to the other test for its sufficiency, right? So this is called dimensional analysis. So in this manner, we conclude this chapter. Some one or two things are there. Order of magnitude. Order of magnitude. For it is a standard practice in writing the quantities magnitude of various quantities, that it is expressed in the power of 10. Like we have just seen that speed of light is 299 and so many figures were there. In short, it is expressed as 3 lakh kilometers per second. Or this can be expressed as 3 into 10 to the power. Oh my God. 6 or 7, whatever is there. 6 meters. I'm not sure about this. It may be 6, 7, 8, anything per second. So it comes out to be very compact while we start writing so many questions, answers, or any calculations. Like dimension and diameter of an atom, radius of an atom. It is very much, very, very small, and millimeter, and then nanometer and micrometer, in the range of nanometer and micrometer. Then the objects are, when very small objects are expressed as a negative power of 10, 5 or 6 or 7 or anything. Like 1 millimeter is expressed as a 10 to the power minus 3 meter. any object is, if 1 millimeter long is having a length of 1 millimeter, it may be expressed in the terms of meter, but this term is also associated with it. Suppose we want to say that I have a pen which is 5 centimeters long. I can say that 5 into 10 to the power minus 2 meters. In this way, it is easy to express things in one single unit. Somebody may use micrometer, somebody may use millimeter, somebody may use centimeter and meter and kilometer and decimeter and decameter and million meter. These things are not required. Only start expressing thing in the one unit, that is meter, that is a standard unit. Just add 10 to the power whatever the range is. सेंटीमीटर का पेन है तो 5 into 10 to the power minus 2 कर दो, और अगर लाइट की वेलोसिटी लाखों में है तो उसको जो है 3 into 10 to the power, यहाँ पे ज्यादा है तो ये 8 कर दो. इस तरह से होता है. या मान लो कि अगर हमको न्यूक्लियस एटम का रेडियस अगर निकालना है तो इट में बी एक्सप्रेस एज 5.1 into 10 to the power minus 9. इस तरह से कर सकते हैं. उसको बहुत ऐसे लिखने की जरूरत नहीं है. 0.000000051 ऐसे लिखने की जरूरत नहीं है. जीरोस इस तरह से लगा के हम लिखते हैं. ये दोनों इक्वल नहीं है, कुछ कम बेसी हो, कम ज्यादा हो सकता है, लेकिन सिंगल तरीके से अगर हम लिखना शुरू करें तो ये ऐसे हम लिखेंगे. इट विल बी हाईली कंफ्यूजिंग. आई एम putting 1 2 3 4 5 6 7 zeros here, and somebody may by mistake he may read 8 zeros or 6 zeros, then whole thing will be wrong. So it is better that write it like 5.1 into 10 to the power minus 9 or 8 or 7 or whatever you like. Clear? So this is the order of magnitude. Means we always express thing in such a way that it is very compact and it is always expressed in standard units. So no need to use centimeter or kilogram or tons or milligram or centigram or microgram. Just express thing in the grams or kilograms. One may say that the weight of earth is so many thousand or million tons. So many million tons. In expressing in such terminologies, and expressing is 5.7 into 10 to the power 11 kilograms. This is rather simple and standard, compact also, and is not having any confusion, right? So this is the advantage of expressing physical quantities in this manner. Only one unit is required, that is kilogram or ampere or anything, we may get high currents also, like lightning. When lightning is occurring, we may have millions of voltage, million volt in that particular phenomena. Rather than writing million volt, we write the quantity and put it like volt. That is equal to million volt or ampere or any other thing. Right? So in this manner, we have the tradition of expressing physical quantities. With this, we are concluding this chapter. And next day, we will study the next chapter, which is physics and the mathematics. So that's all for today. See you 4 p.m. tomorrow. Till then, goodbye. Have a nice time.